Our last lesson for Unit 6 is going to be writing equations in two variables. So again, we're sticking with equations, but we're going to bring in two variables as opposed to one variable like we've been working with in the past. Our learning target is writing equations in two variables and then analyzing the relationships between the two quantities. You should be able to determine whether an ordered pair is a solution of an equation in two variables. So if you remember that term ordered pair, we've looked at that in the past, but we'll take a look at it again. This word solution, that's part of our Quizlet vocabulary. So again, we'll bring that back up in this lesson here. We also want to distinguish between independent and dependent variables. Now, those are two terms that you hopefully remember from science class, and science and math are very connected, and we'll take a look at what those variables look like in math, because there is a connection between that and science. Writing and graphing equations, and then creating equations using real life problems. I'm not sure how many of those we'll take a look at today, but those are some of our success criteria. So let's shrink this. Let's bring this up. So when we have equations with two variables and we start graphing, keep in mind that the variables in an equation are the two variables that would be the x and the y axis on a graph. Okay, so when we talk about the x-axis, we're talking about this horizontal line. And so in math, this would be our independent variable that we're looking at in an equation. And then the y-axis, this vertical line, that is going to be our dependent variable. So when we talk about independent and dependent variables in equations, and then we plot them onto graphs, that's where we would start plotting our points. And so we would move left and right if we're looking at an independent variable, and then we would move up and down when we're talking about the dependent variable. So in this situation, we have time on our x-axis, and so all of these values up here in this data table would be measurements of an independent variable. And then the distance, which is the y-axis label, located here in our data table, those would be the dependent values. But before we start graphing, let's take a look at what equations will look like with two variables. So an equation in two variables represents two quantities that change in relationship to one another. So if you think back to science class, whenever you change something as a scientist, if you remember, that's our independent variable. And then the dependent variable depends on that change. And so it's the exact same in math class. And so our independent variable is going to be the variable that's within the equation that is not left alone, okay? And so when I say left alone, I'm talking about this y right here. So if we're saying that y equals 2x, whatever y is going to depend on what x is. Okay, so if I make x 1, then my y, I know that it's 2. If I say that x is 2, 2 times 2 is 4, so y is going to be 4. And so x is my independent variable. It means that I'm going to change this, and then the y value is changed after. Okay, or the y depends on the x. And so the y is that dependent variable. So this would be my dependent variable, and then the x is my independent. And so when we look at, let me erase some of this. When we look at a question like this, where it says, we're talking about solutions again. When it says identify whether the ordered pair is a solution of the equation, what we want to do is we want to plug in our ordered pair, which if you remember, the ordered pair looks like this. It has two values in parentheses separated by a comma. And in all situations, an ordered pair has the x value first and then the y value. And so my 3 is my x value, which means I'm going to plug it in to my equation. So this is going to become, I'm just going to write that stuff over here. Y equals 2, and x is going to be 2, so I'm going to substitute, sorry, not 2, 3. X is going to be 3. So I'm going to substitute 3 in for x, and then I'm going to solve for y. And so simply 2 times 3 is 6, and so y equals 6. And so then I check to see if in my ordered pair my y value, right, the number to the right, is 6. And if it does match, if it is correct, then I would say yes, 3 comma 6 is a solution in that equation. Okay, so again, a solution is when the left side of an equation matches the right side. So we'll look at an example here to the right that shows us an example that's not a solution. So again, here's my equation. It has two variables, y and x. Again, x is independent, y is dependent. So I'm going to put 4 in for x. I'm going to substitute. So I get 4 times 4. And then I solve this. 4 times 4 is 16 using order of operations. 16 minus 3 is 13. And then 12 is my y value, since it says that right there. And since 12 and 13 are not equal, I would say that 412 is not a solution to this equation. So again, it's all about matching the left side of an equation with the right side. If it doesn't match, if it's not equal, we say it's not a solution. Let's get rid of some of this. That's not shrinking. There we go. Shrink that one. And so the last thing we want to look at is graphing equations. And this is probably something you're familiar with. I can't remember if we've done much of this year. So when we graph a solution, we have the option of plugging in as many values into an equation as we want. So we have our x value in this equation, y equals 2x plus 1, and we have our y value. When we graph equations, we have the option of plugging in any values we want in for x. And so taking a look at this table right here, you can see they entered 4 values in for x. And oftentimes we just go simply 0, 1, 2, 3, keeping it simple, not getting too extravagant with those numbers. When you start putting values extremely large in for x, then when you start graphing it, the axes are going to have to be really large, or the numbers that you mark on your axes. And so oftentimes when we graph, if we want to look at what the shape of the line is on a graph, we just keep it simple by using small values like 0, 1, 2, 3. But in all honesty, whatever numbers you choose to input in for x, the shape of the line will be the same because a line goes on forever. So the quantities actually don't matter. But to keep it simple, I would encourage you just use small values like 0, 1, 2, 3. And so we plug 0, 1, 2, and 3 into the equation, and then we solve for y. Okay, so if I put 0 in for x, and I solve that, 2 times 0 is 0, 0 plus 1 is 1. So it ends up saying y equals 1, which is why you see 1 over here in this column for the dependent variable y. And so these two terms, not terms, these two values, 0 and 1, become my ordered pair 0, 1. Again, paying real close attention to the order. X is first, and then y is second. So 0, 1. And we're going to do this 4 times, inserting our independent variable, solving for y, and then that becomes the dependent variable y, which gives us our ordered pair. So here it's 1, 3. I insert 2, I get 5. 2, 5 is my ordered pair. Insert 3, solve for y and get 7, so my ordered pair is 3, 7. Now all of these ordered pairs are what I use to make a graph and make a line on a graph. So if you remember how we graph, we always start at the origin, which is where 0 and 0 meet. I encourage you to move in order from the x value to the y value, even though you can really go either way. I like to just get into the habit of getting into a routine. So 0 will tell me which direction or how far I go on my x-axis, which is left or right. And so in this case, since it's 0, I'm not going to go left or right. I'm just going to stay put right at the axis. The 1, my y value, tells me where I go on my y-axis. And so since it's 1, I'm going to go up 1, which is why you see that dot right there, that point, and then the ordered pair 0, 1 right next to it. For the second ordered pair, 1, 3, again, start at the origin. 1 tells me to go to the right 1, and then positive 3 tells me to go up 1, 2, 3, which is why you see the plotted point 1, 3 there. Okay, so all of these get plotted on the graph. All 4 points. And then we connect those points with a line, and that tells us, or that shows us the shape of this line. So all equations with 2 variables can become a line on a graph. Okay, and so we're just practicing plotting in points for our x values, getting our y values, creating an ordered pair, and then graphing. Okay, I hope that was helpful. This was our last lesson in Unit 6, and it's all about writing equations with 2 variables.